All right, so far we have just practiced using the three formulae used in stoichiometry to find unknowns. And the other thing that you did on Wednesday, you created a standard solution and then you diluted it twice. That's what you've done so far, okay? It started off a bit rough, but as you got the hang of it, it wasn't too bad. I was impressed because normally we don't do this until next year. So those skills that we are building right now is going to allow us to put stoichiometry into action to work out the amounts of products and reactants that were involved in a known reaction. Remember that in a chemical equation, the large numbers to the left of the chemical formula indicate the ratio. So this is a reaction that you might encounter a lot if you were to do chemistry in year 11 and year 12. If you burn methane, so that's farts or gas that you have in barbecues and stuff. If you burn methane in oxygen, you get carbon dioxide and you get pure water. If you look at this equation here, is it currently balanced? If I look at the C's on the left, how many C's on the right do I have? 1, so that's balanced. If I've got 4 H's here, how many H's do I have on the right? That's not balanced right now. I can't change this to H4O because then it's no longer water. The only thing that you have control over is the number in front, which is 2. Is the amount of H now balanced? Do I have 4 H's on the left, 4 H's on the right? Let's look at oxygen. I currently have 2 oxygens here. But now what do we have? 1, 2, 3, 4. So what correction can I apply? 4, 2. Good. We need 4. We achieve that by getting 2. But where does this? Suddenly there's maths in your science. Yeah, that's why we teach it to you. Every 1 lot of methane, right? Every 1 lot of methane, how many lots of oxygen do I need to burn it with? According to this, 2. Every 1 lot of methane burned in 2 lots of oxygen produces how many lots of carbon dioxide according to our balanced equation? 1 lot of carbon dioxide. And how many lots of water? According to that, what's the number in front of H2O? 2. 2 lots of H2O. Okay? So if I didn't have, I don't know how much I'm using, but if I didn't have double the amount of oxygen to methane, this isn't going to work. Okay? Let's talk in moles. If I had 1 mole of methane, how many moles of oxygen would I need? 2. And I would produce how many moles of carbon dioxide? 1. But I'd also produce how many moles of 2. That's what the balanced equations are for. It tells you the ratio. So in any reaction, hopefully you see from that, in any reaction, if we know the amount of one of the substances, we can find the amounts of every other substance involved in the reaction. So this is a reaction between sodium sulfate, Na2SO4, and barium nitrate, BaNO3, 2, produces a precipitate of barium sulfate with a mass of 2.44 grams. So you have this equation here, and I'm telling you that after this equation, I measured that I had 2.44 grams of this. And what I'm telling you is that because you have 3 formula, you can work out exactly how much grams of this you produced, how many grams of this, how many grams of friggin' everything. Is this balanced though? How many sodiums do I have? How many sodiums do I have? So what do I need to do to the front of that to correct it? 2. But the problem is it might affect everything else, so we need to check. How many sulfurs do I have? No, that 4 is just 1. How many sulfurs do I have here? So that's okay, leave it alone. How many oxygens?
4.
No, because there's some oxygens here too. How many oxygens here? 3 times by 2. 6 plus 4. How many oxygens do we have here? 4. And 3 times by 2. Do we have 10 on both sides now? That 2 fixed everything. How many bariums do we have? 1 and 1. All good. How many N's do I have? N, but it's in brackets, it's times by 2. How many N's are here? 2, because of the 2 out the front. It's all balanced. I'm challenging you. We're going to do this together. Find the mass of sodium sulfate. So I'm asking you, how much of this was used to produce that 2.44 grams of this? So if you imagine in your head, I mixed 2 liquids together. And in that, when I mix those 2 liquids together, I get a big solid. I don't know what color this is, but it's a solid. And it would precipitate out. And I filtered that out and I dried it up. And I measured that I had 2.44 grams of this. I can use that information to work out everything. So let's apply that. Can you tell me what are the ratios of reactants and products? How many lots of this do I need? What's the number in front of it? 1. So the ratio is 1. 1, 2. How many lots of this do I need? 1. 2. How many lots of that do I get? How many lots of the last one do I get? 2. So your ratio is 1 to 1. What are you after anything?
It's us.
Yeah, you chill out. You can go grab a coffee and stuff. I'll take care of them. Or you can watch. So if I reacted, all right, so we're progressing through the thinking. We've got this ratio. This 1 to 1 to 1 to 2, I don't know the amounts right now. But what if I said, shh. If you want to get up here and do it, that's fine. You drop this, that's $1,600. If I reacted 1 mole of sodium sulfate with how many moles of barium nitrate? What did you say the ratios were? 1. So it would take 1 mole. I would get how many moles of barium sulfate? 1. But how many moles of sodium nitrate would I get? 2. But we're not talking moles. The only thing I know is how many grams of this stuff did I get according to the question. I got 2.44 grams of that stuff. So I have 2.44 grams of barium sulfate from the reaction. Can I work out how many moles that is? Which formula would I use? Would I use the concentration volume formula? Would I use this? Good. You're getting in now. We have a toolbox. I have the number of moles. Number of moles, N, is equal to the mass. Do I know the mass of that barium sulfate that I got? 2.44. I don't currently know the molar mass, but do I have a periodic table to work that out? Okay, can you please do that now? Yeah, do this N, 2.44 divided by, what is the molar mass of BaSO4? Use your periodic table if anyone needs one. I've got a spare here. No, there's a BR, and there's a BA, and there's a BE. Someone tell me the mass of BA. 137. S.
Sulfur's 32.06. Plus oxygen.
How many oxygens are there?
16 plus 4. Calculator.
Have a calculator out, get your device. As soon as someone can tell me how many moles there are, call it up, please.
That 233.36. Is that it? Oh wait, no, divided by.
How many moles? It's a small amount.
0.01. 0.01.
Yes? There's more numbers there though. 0.01. 0.
I did it so badly. I did it the wrong way around.
0.05. Good. To 4 decimal points, moles. All right, shush now. So do I even have close to a whole mole of that stuff? I've got a tiny fraction of it. So based on that information, if you know that you had 0.0105 moles of this, according to our ratios, how many moles of this would I have had? The same? What's the ratio? You told me. The ratio is 1 to 1 to 1 to 2. So I have equivalent number of moles here to this. And you just told me that you had 0.0105 moles of this. So how many moles of Na2SO4 would be involved? The same thing. 0.0105 moles of sodium, Na2SO4 were used in the reaction. Because what's the ratio? This one is the same amount as that, is the same amount as that, but this one has what? Double the amount. Okay? How many grams of Na2SO4 were used in the reaction? Do I have a formula that relates the number of moles with the mass and the molar mass? Can I use that same exact formula? How many moles of Na2SO4? Well, we just worked that out here. So N is equal to small m over big M. How many moles did we just say sodium sulfate was? 0.0105 equals the mass we don't know. Do I have a resource that can work out the molar mass of this new? Work it out for me. How heavy is 1 mole of sodium sulfate? Tell me the numbers to add together. How heavy is sodium? Yep. How many sodiums are there? How many sulfurs are there in that? How heavy was sulfur? And what's the remaining? Oh, there's 4 oxygens. 4 lots of 16. 64, so we need to add those up. 22.99. When you get the molar mass of this new substance, can you please let me know? Molar mass, sodium sulfate. 1 something.
Bro, every time I ask
Mate,
him,
I'm
he
gonna
comes up
work
with a
on
new
it.
story.
I'm gonna be waking
At
up with
first,
these.
he was talking crap about Layla Piss, and that's why.
Isn't it 22?
Then he was actually
0.99 times by 2? That can't be 1.
period of time, so that's why he got that. Then the talking crap about Layla made his contract end faster, so they just fired him sooner.
Oh, did you work it out already?
Why did he talk crap about
I was
it?
just asking for the molar mass.
Wait, does Layla work there as well?
Yes, good. All right. Shh. 142.06? 04? All right, mass in your chemistry. I want to know the mass in grams. But that's not what it's set up for. What's the opposite of dividing by 142.04? Timesing, well done. Times by 142.04. That's going to cancel. Times by 142.04. What did you get? I can't say the name, it's recording. So mass is equal to 1.49 grams. Can you see how what was the only thing that we knew about this reaction? I had 2.44 grams of this. Then you use the equation to work out the ratio as 1 to 1 to 1 to 2. And now we know how many grams of sodium sulfate was used at the start. Your challenge now, because I want to shut my mouth. can you please use these calculations example? Can you work out how many grams, what mass of the other product was produced? NaNO3 produced in this particular reaction. Go. I've worked it out. I'll give you like
Okay.
until 10:2. Can you please work out in that reaction?
Lewis, me on you.
I'll copy. Before I stop, I'll copy and paste this formula down again.
He's cheeky with it.
Alright, what's NA? NA.
Sodium.
Sodium, 22.9.
2.99, but you, I guess.
Okay, so this is the one with the ratio of 2.
Yes, how else could it be?
Lewis, can you do
22.99 times 2. So we'll do that, we'll just do this out.
nitrogen is 14.01.
22.99 times 2. Plus, and nitrogen by itself.
7 minutes.
Lewis did this.
10:2, I'll get back to you.
22 point. Get off my
So
book.
I'm asking you, I want you to tell me if this reaction happened and produced 2.44 grams of this, how many grams of this did I produce? You can't.
14.91.
Can you just times 2.44 by this? Yes or no? No, because a mole of this isn't the same mass as that. It's not that many.
So we need to find out.
Yeah, we have to times it by 3 because it's 2.
There's more. Hello?
3 times 6 is 18.
Sorry.
Why wouldn't it?
48 oxygen.
Does a mole of the only thing that the ratio tells you is 1 mole of 1 mole of this mixed with 1 mole of this gives you 1 mole of that, but 2 moles of this.
I wish I could press the button, but it's stop.
You're saying double the mass. It's not moles. The masses aren't in ratio. The moles are.
Plus 14.01 times.
What has to do like addition?
What's in the brackets on that last one?
It just says AQ, means aqueous. So if you, it's in solution. So if you ran this reaction, I think those would be 2 clear liquids, and you'd mix them together, and then suddenly a solid would appear, it would precipitate out, and this would be see-through as well. And so if you did this reaction, what you could do is like pour out the liquid,
Wait, is that what we
and
need
you'd
to
be left with the solid. You can let it dry out, and you can measure how
What do we
heavy.
need to find?
The maths.
I have found the mass. It's 170. Is it not? No, wait, no, that's, yeah. What?
Yeah, how many grams of this do I get?
Oh, how many
If this
grams?
reaction produced 2.44 grams,
Okay, so the number
That.
of moles equals molar mass over.
that would be, Jesus Christ. Damn girl, 170.
70 grams.
That's the molar mass for all of it.
Okay.
The amount
Adding it all up.
the amount of moles is 1, 2,
Yeah, then we're gonna find out the grams though. So using this.
Let's see. How can you do it?
Because we're gonna
Wait,
find out
there's
how
2 people out.
2.44 grams.
Do you know where to start?
We found out the.
No, so we need to get the 0.01. You know what I'm talking about?
Yes.
0.01. It's the reverse of it. It's the one, it's the other, it's the same formula, but it's a reverse version of it.
All right, I'll give you a hint to get you started. Stop for a second. We used the 2.44 grams of this to work out how many moles of Na2SO4 was used. 0.0105. Therefore, 0.0105 moles of this was used. Therefore, 0.0105 moles of this was used. If this is 2 lots of it, what would I times 0.0105 by to get how many moles would? And then could you work out the mass of that 2 mole?
0.5.
34.
So is it 34 or not? Is that well off?
Yeah, let me write that down. Cross it out. 0.0.
Wait, then what do we do after we find out?
I want to show you that.
Times that
Do you know
by
that?
170.
Yeah, I worked it up.
Times it? Okay.
Yeah, multiply that by 170.
So I got this, which is 170, which is the mass, molar mass of all of it. The number of moles is 5. Adding all of that stuff together.
Yep.
The number of them is 5. And 170 is the molar mass. We need to find out the mass in grams. So then
Did you get to 0.021 times by 85?
it's algebra again, finding out. We times it by n, so then 5 then. Then you just divide it by 5.
U times 0.0105 by 2.
Yeah. You get it? Oh. You know how to do algebra, don't you?
That's what I call my leader.
Oh, you're quick then. This is literally just algebra.
How did you get 85? So we not meant to find out?
All right, stop. Let's bring it together now.
Maybe not.
I'll do it in red. So hopefully we established if you used 0.0105 moles here, because of the ratios, you would have used 0.0105 moles here, 0.0105 moles there. But how many moles would I get of the last one? Double that? 0.21 moles. Okay. Now we have a formula. Number of moles is equal to the mass of something over the molar mass. Do I know how many moles of this substance I'm going to get? Yeah, that's what we just worked out. 0.021 is equal to the unknown mass. We need to find the molar mass of sodium sodium nitrate, I think it was. So sodium was 22.99 plus N 14.01 plus 3 lots of 16. So 0.021 is equal to mass on calculated time. 3 lots of 16 plus 14.01 plus 22.99. I get 85. What's the opposite of dividing something by 85? Timesing it. 85 times by 0.021 is going to tell me I get a mass of 1.785 grams of that stuff. So it's not as simple as just doubling this, because does an amount of substance always have to weigh the same? I don't know what the substance weighs. Okay, this is probably less dense. Okay, I'll start that recording there. I think you do need some